Suppose you have a disk of radius 1, and you have 7 smaller disks each of radius r. If the value of r is big enough, you can easily cover the unit disk using the 7 smaller disks. If the value of r is too small, it will be impossible to do so. What is the smallest value of r so that we can cover the unit disk with 7 disks of radius r? This is a nice little problem that you can use to challenge your friends. There are two parts to this solution. The first is to show that the answer actually has a valid construction. And the second part is to show that no smaller values of r than the answer will actually work. So spoiler alert, the answer to this question is r equals to half. And we have the nice pattern over here that is able to cover the unit circle. To show it more easily, you can put in guiding lines as shown. So the blue dots represent the centers of the small circles. And over here we have a pattern of equilateral triangles, each of side half. So if you stare at this diagram long enough, you'll be able to convince yourself that this pattern indeed is able to cover the unit disk. I would like to show the more interesting part of the proof, which is to show that any value of r less than half fails. So to do this, what we are going to do is consider the unit disk as well as a small disk and ask ourselves the question, what is the maximum fraction of the whole circumference that can be covered by such a small disk? So let's say A and B are the points of intersection with the unit disk. And to show the maximum, we consider the line segment AB because the part of the circumference that is covered is the arc AB, and this grows in tandem with the line segment AB. So we want to bound the maximum case by thinking what is the maximum the line AB can be. And in this case, AB is at most the diameter of the green circle, which is 2r, and then since r is less than half, that would be less than 1. And so now to consider what is the fraction of the circumference that is covered, we can look at the angle that it makes with the center of the blue circle. By using the cosine rule, or by directly comparing against the case of an equilateral triangle but realizing that now AB is shrunk further to be less than 1, we see that the angle subtended will be strictly less than 60 degrees, which is actually 1/6 of the 2 pi around the center. This means that the circumference covered by any such small disk will be strictly less than 1/6 of the full circumference. Therefore, we need more than 6 circles, or all touching the circumference, in order to fully cover the circumference. But at the same time, we also need a circle to cover the center. And notice that any circle with radius less than half cannot reach the circumference and the center at the same time. Therefore, these two statements together shows that we need more than 7 circles in order to cover the unit disk. What we have looked at is a special case of the disk covering problem. The disk covering problem asks what is the smallest radius that we can have so that we can cover the unit disk with n disks of radius r. And what we have looked at is the case n equals 7 with the answer half. And in general, this problem has been solved for small values of n, some of which can be quite difficult to prove. For example, the proof for n equals 5 is actually quite difficult. If you would like a challenge, I would recommend instead to work out the answer for the case n equals 3. Feel free to share your solutions in the comment section below. That is all we will cover in this video. Hope you enjoyed the problem. Stay tuned to the channel for more videos in 2023, and Happy New Year!